So we've already talked about viscosity. Remember, in order for a fluid to be an ideal fluid in the fluid flow, it has to have a low viscosity. It can't be very sticky or thick. Viscosity describes how thick a fluid is, and different materials have different viscosities. Temperature, as you might expect, does affect the viscosity. If I have a liquid that's really cold, not frozen solid, but nonetheless cold, like a early cold syrup, that's just going to flow more slowly than a warmer syrup. Usually, cold is more viscous. Almost always cold is more viscous. The viscosity also affects the flow rate. Viscous fluids, like blood, need a constant pressure to make them flow. Because remember, when we were talking about, what was that we were talking about? Laminar flow, that we said that uh, these parts closer to the side will travel more slowly. It's like they stick to the side. And the higher the viscosity, the more it's going to stick. Non-viscous fluids, on the other hand, do not need a pressure differential. Superfluids, and I have a video I want to show you. I don't know if this is in your book, but it's interesting nonetheless. So superfluids have no viscosity and will travel through barriers with no resistance. There is no, you can think of it as no friction between the atoms of the superfluid and the atoms of the barrier. And I'll show you a video where it has a little cup. And in that cup is a superfluid. It is liquid helium, which is helium cooled to a very, very, very cold temperature, which is really close to absolute zero. And towards the end of that video, it doesn't look very impressive, honestly. But if you think about what's going on, is these little particles of helium which are in this cup, otherwise they would be contained and they would come up to this wall right here and they would not pass through it. Okay? But when you cool them down so that they become a superfluid with no viscosity, these little particles of helium just travel right through that barrier as if it's not even there. It's like walking through a wall. Okay, the molecules of the superfluid don't interact with the molecules of the barrier and they just pass right through. And I think that's really remarkable. So you could see a question about that on your test or your quiz, and please watch this video that I'll put in the link.